Hello everyone. In today's lecture, we are going to discuss Cohen Sutherland line clipping algorithm. Actually, in previous two sessions, we discussed about windowing and clipping. Till now, we have discussed what is meant by window, what is meant by viewport. Then we have seen that what is meant by clipping. After that, clipping are of various types, that is nothing but point clipping, line clipping, polygon clipping and character clipping. Okay, already we have discussed a point clipping. In case of a point clipping, points are clipped against the window. Okay, if suppose this point with coordinate x comma y, the window is represented xw min yw min, xw max yw max. The point will be inside is xw minimum less than equal to x and x is less than equal to xw max, and yw mean is less than equal to y and less than equal to yw max. Then and then only that points will be inside the window. Okay, now next point of the discussion next point of a discussion is line clipping. Okay, so what do you mean by line clipping and line clipping algorithms? Here, line clipping means what? Okay, so finding the part of a line which is inside the window, you have to show that part. Okay, and whatever part or whatever line which is outside the window, you have to discard it. For example, here are three lines. Okay, so suppose this is a line A B. Okay, this is a line C D and this is a line E F. Okay, so if you compared first line if you compared first line AB and this window, okay, against that window, okay, you have to clip the line and window. Okay, if you compare line AB with the respected window, it found that line AB is totally outside the window. So that so that we have to discard the line. Okay, whenever it will clip against the window, at that time nothing will be shown of a line AB. Okay, now go to the comparison of line CD. As you can find, line CD is line CD is line CD is complete line CD is line CD is completely inside. Okay, inside the window, so it is accepted fully and you can show CD as it is. Okay, now go to the line EF. In case of a line EF, you compare with the window some part of a line which is outside the window and some part which is inside. Okay, so this much part is inside the window and this much part is outside the window. Okay, so you have to remove this part and you have to accept this part. Okay, means you have to remove this part. Okay, and you have to accept this part. Okay, means what will be the output after clipping the window? clipping the line against window is, so hmm? So CD will get as it is. So CD will get as it is, and line that is clipped after, that is E dash and F dash. E dash and F dash. So that new coordinates you have as E dash and F dash. So this is called as a line clipping. Here we can see through eyes, okay, and we can compare it. But in case of computer, it is not possible. So there are few algorithms for removing this unwanted part and accepting the interested part of a window. So there are various algorithms we have in case of a line clipping. Okay. So first algorithm, that is nothing but Cohen Sutherland line clipping algorithm. Next algorithm is Lian Basky line clipping algorithm. Okay. And next algorithm is midpoint subdivision line clipping algorithm. Okay, and one more algorithm is there, that is Cyrus Bake line clipping algorithm. Okay, so now we will discuss Cohen Sutherland line clipping algorithm. Okay, so Cohen Sutherland line clipping algorithm is oldest and most popular algorithm. Okay, most popular algorithm. Suppose there are, if suppose there are line AB, line CD, and line EF. Okay, there are three lines. Whole whole whole. This is a window. Okay, and against that window we have to clip the lines. So there are three cases. Okay, one case is line will be totally inside the window. Second case is line is a totally outside the window, and another case is line is somewhere clipped by window. So so three cases along with the steps will be discussed in a Cohen Sutherland line clipping algorithm. In this algorithm, we have to find region codes for each endpoints. Okay, each endpoints of the line. Here you can compare with line AB. A is a endpoint with a coordinate x1, comma y1, and B is a with coordinate x2, comma y2. Okay, so what you have to do, you have to find region codes in case of Cohen Sutherland line clipping algorithm. So those region codes will be in terms of bits. Okay, so there are 4 bits you can call the TPRL. Okay, so related to so C is related to top, B is related to bottom, B is related to bottom, R is related to right, and L is related to left. Okay, so you have to assign 4 4-bit region code. Okay, now how it can be assigned, I will show you. Okay, so suppose this is a window. Okay, so neither it is on a top, okay, nor in a bottom, nor in a left, nor in a right, nor in a left. Okay, so so it is no, so it is not in a left. Okay, so it is 0. Okay, not in a right, so it is a 0. Not in a bottom, so it is 0. Not in a top, so it is 0. So it is 0 0 0 0. Okay, this is the inside region of, this is the inside region of a window. Okay, so now see, this is the, this is the left of the window. Okay, so that left bit is, so that left bit is a 1 and all other are 0. Okay, so this is a right region. Okay, right, so that second bit is a 1 and remaining are 0. If you compare this particular region at the bottom, so that all bits, so that all other bits are 0 except the bottom bit. Okay, except the bottom bit, that is third bit. Okay, and this is the region code which is the top of the window. Hence fourth bit, that is the fourth bit, that is the top bit is a 1 and all other are 0. Okay, now we have seen, now we have seen region code for 4 different regions, that is nothing but top, left, right and bottom. Okay, so what about this region? Okay, this region towards the left side. Okay, this region is, this region is toward the left side and as well as it is in a bottom. Okay, so that region code for this particular region, 4-bit code is 1 for a, 1 for a left. Okay, 1 for a left, 0 for a right, 1 for a bottom and 0 for top. Okay, similarly you can, similarly you can compare this. Okay, this region is above the window as well as it is on a left side, so that left bit is a 1, right bit is a 0, bottom bit is a 0 and top bit is a 1. Okay, so similarly you can go for this region. Okay, so this is nothing but the right side region as well as bottom side of region. So that 0 for a left, 1 for a right, 1 for a bottom and 0 for a top. Okay, so of this region which is right side as well as top, so that 0 for a left, 1 for a right, 0 for a bottom and 1 for a top. Hence, those are the regions. Okay, there are 9 regions. Okay, total 9 regions. We have divided completely this one into 9 regions. Okay, and we have assigned the region codes. Okay, I think you have understood how the region code will be found out. Okay, so the region code is nothing but 4-bit code based on the position from a window. Okay, so inside the window all the 4s are 0. Okay, if suppose if suppose line is a like this. Okay, line is a like this. Okay, uh, so what code for AB is A B. Okay, mm, so code for B is, so code for A is for code for A is 0001. Okay, and code for B is 10100. Okay, you have to find the region codes for endpoints of the line. Okay, now we will come towards the actual algorithm. Okay, in case of Cohen Sutherland algorithm, what you have to do, suppose suppose uh, any line, or suppose this line and region code for both endpoints are 000. It means line is totally inside the window. Okay, line is totally inside the window. Okay, you have to accept the line and you have to move further. So these particular regions are helping you to find which line are completely inside. Okay, the window, which line lines are completely inside the window. Okay, and which lines are completely outside the windows. Okay, or which lines are partially inside. So you can reduce your calculation. If you found that line is a completely outside, it shows that there is no need to compute outside line, means you are reducing the number of calculation. If suppose line is completely inside, in that case you have to accept the line, no need to clip it. Okay, so when you want to clip the line, if the line is a such a type. Okay, so candidate somewhere it is clipped by window. Okay, so it is clipped some part of this line is, some part is, sorry, some part is outside the window. In that case you have to some more calculations, so that this part is neglected. Okay, so this part is neglected and okay, this part is accepted. Okay, so that this is nothing but the how Cohen Sutherland algorithm is. Okay, so move towards the line clipping algorithm. Okay, so what are the steps of Cohen Sutherland line clipping algorithm? Okay, so the first step is you have to accept the line endpoints a x1 comma y1 and b x2 comma y2 and window coordinate xw minimum, yw minimum, xw max and yw max as a input. So first of all you have to accept the line endpoints x1 y1, x2 y2 and window coordinates xw mean, yw mean, xw max comma yw max. After accepting it, after accepting it after accepting it, as we have calculated region codes by seeing the regions, but it is not possible in a computer, so you must have some formulas for calculation of that region code. Okay, so what are the formulas you can calculate region codes for a line endpoints? If suppose b1 for a left, b2 for a right, b3 b3 for a b3 for a bottom and b4 for a top. Okay, so xy point. Okay, for xy point. Okay, so how you can calculate b1? B1 is nothing but the b1 is b b1 is nothing but sine of xw minimum minus x. If this value is, if this value is greater than 0, it means that you have to put b1 bit as a 1. If this value comes to minus, that time you have to put this value as a 0. Okay, then similarly you can calculate b2 as a b2 as sine of x minus xw max. Okay, and b3 is equal to sine of yw minimum minus y, and before is before before is equal to sine of y minus yw max. Formulas are, so those formulas are used to calculate region codes, that is nothing but b1 b2 b3 b4. Simple. You have to put the values of x minimum and x. If value comes positive, if value comes positive, then b1 bit will be 1. If the value is a negative, at that time b1 bit will be 0. See, so this is nothing but how region code can be calculated. You must remember those formulas. If you remember first two formulas. Okay, if you remain it xw mean minus x, and y yw mean minus y, the same formulas, there is change in x and y. Okay, so now after finding the region codes, you have to decide based on a region code. As we know, in case of a window, the line is inside the window. At that time both region codes comes 0000. It means that if the region code for both endpoints of the line are 000, then line is totally inside. You have to accept it and how to stop. No need for a further, because it is not clipping candidate. Okay, the window is not clipping the line at any point, means it is accepted as it is. Whenever region code for both endpoints are 0 0 0 0. Okay, remember both endpoints are 0 0 0 0. Okay, not for a single endpoint. Okay, if region code for both endpoints are 0 0, then line is totally inside, you have to accept it. Okay, so this is a one case. Okay, there are various cases. Okay, there are various cases. Okay, so this will be another case. Okay, uh, so the first case, if the region code are 0 0, it means that line is a totally inside, you have to accept the line and you have to stop here. In case, okay, in case of lines whom region codes are non-zero, then you have to take and value and a and operation. Okay, means adding values. Okay, if suppose it is a it is a okay, uh, if suppose it is a 0 1 0 0 and it is a 0 0 1 0. Okay, so what is the ending operation? Means uh, we have to add. Okay, add the bits. Okay, so first bit is a 1 0 0 0 and second is a uh, 0 0 0 0. Okay, so what is the ending operation? Hmm? You have to remaining that 0 0, that then 0 is out. If it is 0 1, then it is 0. Okay, if it is 1 0, then it is 0, and it is, if it is 1, if it is 1 1, then it is 1. Okay, so we calculate here, here 0 0 10. Okay, ending part. So 0 0 0 0 1 0 0 0 0 1 0 0. Okay, so if line is a non-zero, then it is a totally outside, you have to discard it. Okay, if and of a region code is a 0, the line is a clipping candidate. Okay, means somewhere line is clipped by window. Okay, so there are three cases, you have to remember those three cases. Okay, so what are those three cases? If suppose both endpoints are 0 0 0 0, it means line is a totally inside, you have to accept it and stop. Okay, so this is the first case. If and of region code is non-zero, then line is a totally outside the window. Okay, so discard the line and stop. Okay, and and if and of a region code is 0, then line is a clipping candidate. Okay, in case of inside line, in case of outside line, you need not go for a further beyond step 3. Okay, but in case if ending of a region code is a 0, line is a clipping candidate, you must go to the step number 4. You must go to the step number 4. If suppose if suppose if suppose this type of line, we must calculate intersection points. How that intersection points will be calculated? For that you must go to the step number 4. What is the step number 4? Determine which boundary is intersecting based on a region code. So this is the region code. Okay, for each region code you have to find which value is a 1. Okay, if b1 bit is 1, then you b1 is equal to 1, have a x dash xw minimum. If b2 is equal to 1, then x dash is equal to xw max. If b3 is equal to 1, then y dash is equal to yw minimum. And if b if b4 is a 1, then y dash is equal to yw max. Okay, so that calculation you will understood at that time. Okay, so you must remember, if first bit is a 1, then you have to consider, if first bit is a 1, then you have to consider x dash is equal to xw min. You can put that value into the formula. Okay, if b3 is equal to 1, then you can calculate y dash is equal to yw minimum. Okay, now how that can be calculated? If suppose determine the intersecting coordinate, if suppose determine the intersecting coordinate x dash y dash using following equations. Okay, when we got y dash is equal to yw minimum, or y dash is equal to yw max. At that time we have to put that value into formula. X dash is equal to x1 plus 1 upon m into y dash minus y1. Okay, you have to put that formula. Okay, if suppose y dash is equal to yw minimum, this value you got, that y dash value you have to put in here, and calculate the x dash. Okay, if suppose you are getting x dash is equal to xw minimum or x dash is equal to xw max, at that time you have to calculate y dash, putting that value into this formula. Y dash is equal to y1 plus m into x dash minus x1. Now after calculation you will get x dash y dash intersection points. Okay, you can find both endpoints, and once it is found, that what you have to do? You have to do step number 2. Okay, so what is step number 2? Again you have to find region codes for newly intersected points, and you decide if region code is 0000, line is inside and accept that part. Okay, so this is the Cohen Sutherland line clipping algorithm. Okay, once we take a problem, you can understood how it can be solved. So in next session we will take one problem related to it. Okay, we will stop here. Thank you.